If you remember way back in that first video, is collaborative. So physics and science is a very collaborative effort anyways, but we want to take it above and beyond just, working together in a lab setting, right? So the first thing in my classroom is we have what we call A2B1, okay? So A2B1 means ask two before one. If you know, we got those great, air purifiers. So what I did was I actually taped this on. We called our little droid, okay, because I'm a Star Wars generation guy, and so he's our little droid A2B1. If you click on the link of the Star Wars emoji there, it'll send you to the protocol. Ask three before me. It's the same thing. The goal is that you have to ask two fellow classmates before you come to me, okay, as the teacher. I want students to go and work together. Maybe they can put their heads together and get this, get the work done, answer the questions, and so forth. But that's going to be built into our classroom culture. So one of the first things that we cover about how we want this to be a collaborative environment. Now, we don't want this to be a colluding environment, right? So there's a difference between collaborative versus collusion, right? So collaborative means we're working together to get the work done, but we're not necessarily like just giving you answers. That's collusion. We're not copying. Okay. I ask students whenever they do like such things as like lab reports or claim evidence reasoning examples that they can work together, but the work has to be their own that they submit, right? I shouldn't be able to read six, assignments and they all say the same exact thing because they all work together and they just literally just copied everything together. So that's, collaborative versus colluding. The second thing that we do to make this collaborative is something that I picked up from the On-Ramps program. It's called peer instruction, and it's from Eric Mazur, who is a physics professor at Harvard. If you want to know more about how he runs this in his classroom, just click on the picture. It's the second picture. That's actually Eric Mazur. Look like he's working with some fellow teachers as well about how do we do this peer instruction model. Basically, the way peer instruction is set up is you present a question to students. They answer it by themselves originally. And then after some time, you allow them to talk about it, right? So it's like you defend your answer or you try to get the other person to change their answer. We don't know who's right or wrong at this point in time. It's kind of like you're taking a poll in the first round of questioning. So I've done this so On-Ramps has access to learning catalytics through Pearson. But I've done this using Pear Deck or Nearpod, right? So you set up a poll. So the first thing is just like, hey, where do we think, what the question is? And then you have a conversation about it. So you're working together. That's that peer instruction. You're either trying to convince the other person to change their answer or listening to them. But the students are talking about it. And then finally, the quote unquote graded portion comes about when you give them the same question the second time. Now they can change the answer or they can keep their answer. And then at this point in time, you've had enough conversation as hopefully, the answer is getting closer to what the right answer is. And I've had cases, in the On-Ramps class where nobody has selected the right answer. Then they had a conversation, or maybe one or two people have selected the right answer. Conversations happen. And all of a sudden, we're going from like 2% correct to now 70% or more, right? The goal for that, UT sets, and I kind of use this when I do it with my AP classes, is 70 to 75% correct. But that doesn't mean that, those students that got it wrong, we don't just leave them hanging, right? We explain it, talk about the answer. They, maybe it's something that they jot down, like, I still need a little help with this. Maybe they turn and talk to a shoulder buddy, or then eventually they do come see me for that extra help. It's a lab based class, so they're going to sit in tables of four, again, encouraging that collaboration. Sometimes I mix it up. Sometimes I let them work with their friends. Lab, I generally mix it up, but just in general, students are going to be comfortable with who they're, where they are, and comfortable breeds, that want to learn because they're with their friends, they're comfortable. But if I see get too comfortable, then I move them around, and they don't like it, but they have to be able to work with other students, just like we do in our jobs, right? So we may, have an issue with somebody else that we work with, but you know what? We have that common goal of getting students the material that they need to succeed in our classes. So we work together, right? Not what a great way to model this for students by doing it ourselves. And then finally, right, physics is a lab-based science. So we're going to be in the lab. We're going to be doing stuff together, hands-on, collaborating, collecting data, working together to analyze the data, and so forth. Again, a lot of my examples do center around physics, but remember, this could be, if it's an English class, you can have the students write an essay, and then they can pass it amongst themselves and have conversations, like, hey, what were you trying to say with this point? I do like this. Um, give those, have those conversations versus just say, hey, you should change it to this or you should change it to that, right? Ask questions, have the students develop that questioning strategy. But again, working together to create this nice collaborative environment and culture in the classroom.